What's going on, guys? Welcome back to the channel. Today I want to talk about extension cords and the importance of using the proper gauge, especially when powering heaters like this one here. A buddy of mine reached out to me recently and was telling me that he had a situation and was concerned. He was using a space heater to warm his studio, and he said that it started to act up recently, and when he would unplug it and plug it into a regular wall outlet, it seemed to work fine. But when he would use the extension cord, it was acting as if it was defective. He said he then disconnected it, and when he looked at the cord, he said that the prong edge of the cord, this edge here, seemed like it was melty and burnt, and the outlet itself showed signs of heating and what looked like was the start of it starting to burn as well. So he was asking me what I thought the cause was, and I explained to him that that was a classic case of using too thin a gauge cord for a device that required a much higher thickness cord to be able to absorb the current that's being flowed through it. So real quick, I just want to explain it so that it's very simple to understand. Most of the time we use cords to power up, our appliances or our tools, and they're a temporary thing. So we don't really see what's going on behind the scenes. But what happens when you plug in a heater like this one, these things on the minimum draw about 1500 watts. So what happens is, when you plug in a cord that's too thin, and we'll get into gauges in a second, but when you plug in a cord that's too thin, just to make it simple, the current that needs to flow through that wire in order for this device to work is high. And being that the cord is too thin, there's a lot of resistance that's created, and that also creates heat. And so what happens is the wire then actually overheats and melts, potentially causing a fire before the breaker can even trip. And that's the issue. Got a little cheat here for remembering. Basically, a 12 gauge wire can hold up to 2400 watts. That's the rating for it. 14 gauge is rated for 1800 watts. 16 gauge is rated for 1560, and 18 gauge is rated for 1200, it looks like. This device here says it works off of 1500 watts. So when it comes to devices like a heater that you're gonna plug in and probably not be around to supervise, you wanna be on the safe side. Even though it says it draws 1500, and what we can see here is that at 16 gauge, we're covered to 1560. When it comes to heaters and things that aren't gonna be supervised, I would err on the side of caution and always use a minimum of a 14 gauge or a 12 gauge extension cord to plug your heaters, because they are one of the leading causes of fires, and it's very important. So a lot of times we just we take these cords for granted. They all look the same, but they all have different ratings. They all have different gauges, and so depending on the application, you want to make sure that you're using the right one. So one rule of thumb I like to go by is, if you're using anything that's a high-powered tool, or if you're using anything that generates heat, like this heater here, definitely ensure that you're using a 14 or a 12 gauge extension cord. This way you don't run the risk of having an accident. All right, guys, so just to recap on wire gauges, I mentioned in a previous video, I explained the difference in wire gauges and how they work. It's actually counterintuitive. So basically, the lower the gauge, the thicker the wire. If you have an 18 gauge wire, it's going to be a lot thinner than a 16. 16 is thinner than the 14, and the 14 is thinner than the 12, okay? So it's very important to understand that. The lower the gauge, the higher the thickness. You want your wires to be nice and thick, because the thicker they are, the more current they can tolerate with the least amount of resistance, reducing the amount of heat and reducing the potential for a fire. All right, guys, I hope you enjoyed the video. I'll see you on the next one. Thanks.